Hello student, welcome to all of you in the next physics lecture. This is the video number 42 and now we have to see here the chapter number 6, the superposition of the waves. Now we have to start here the new points, the characteristics of the stationary waves. Now we have to see here the characteristics of stationary waves. There are a lot of characteristics. Now we have to remember here technically in short these characteristics of stationary waves. First characteristics we have to see in the form of the definition. Stationary waves are produced due to the interference between the two exactly identical progressive wave traveling through the medium along the same path but exactly in opposite direction. Then and then the stationary waves are produced. That means in short, we have to remember this first characteristics in the form of the definition that the stationary waves are the interference between the two identical progressive wave traveling through the medium along the same path but exactly in opposite direction. Then and then the stationary waves are produced. This is the first characteristic, very important. Second one, when there are some point at which the displacement is zero, that means the particles remain at rest, the displacement is zero, then such points are called as nodes. Also, there are some points at which the amplitude is maximum. This amplitude, it should be maximum. Such points are called as an antinode. And these nodes and antinodes are alternately produced when the stationary waves are formed. In these characteristics, we are define the stationary wave first. Secondly, we have to define the node. Third one, we have to define the antinode. Nodes means what? The point at which the displacement is zero, that means particles at its remain rest position, then the nodes are produced. That such points are called as nodes. Also, there are some points at which its amplitude should be the maximum. That means they are not at rest position. They are reaches its maximum height. They are reached at its maximum distance, and then such points are called as a antinode. There are the next characteristics. The distance between the two successive nodes or antinodes is equal to lambda by 2. This is also very important. You can use in this numerical also. The distance between two successive nodes and antinodes is equal to lambda upon 2. Okay. Then when the stationary waves are formed, the nodes and antinodes are alternately produced, and the distance between the nodes and adjacent antinodes is equal to lambda by 4. Remember, distance between two successive node or antinodes, lambda by 2. But the distance between node and adjacent antinode is equal to lambda by 4. This is you have to also use in this numerical. Distance between node to node or antinode to antinode, lambda by 2. But distance between node and antinode, adjacent antinode, is equal to lambda by 4. Okay. And next is that in the stationary waves, the amplitude of the vibration, it should be increases from node to antinode. That means we have to perform here the stationary waves, which can be the starts from the node, reaches at its maximum amplitude, that is the antinode, and regain its original position. In this way, the stationary waves amplitude of the vibration, which can be increases from node to its antinode. Okay. Then the phase does not change from the particle to particle in the production of the stationary waves. The phase which cannot be changes from the particle to particle when the stationary waves are produced. And last one, the stationary waves are periodic in space and also periodic in time. That means time interval between it cannot be changes, it should be remains as it is. And then the stationary waves are periodic in space, and so it is a periodic in time. If we have to how these stationary waves are produced, we can see here. Suppose that this is the stationary waves we can perform here. in this situation there are the same time interval and this distance are also equal, then the stationary waves are like this. You can also draw this stationary waves also. Okay, here node, here antinode, here node, antinode, node, antinode. In this way, the stationary waves are the produced. You can remember this from this example: node, antinode, node, antinode. Then this distance between antinode to antinode, this is equal to lambda by 2, or the distance between this node to this node is also equal to lambda by 2. But the distance between node to antinode, that means this node and this antinode, this is equal to lambda by 4. Antinode, node, antinode, or antinode to node, this is the lambda by 4. But node to node, this is the lambda by 2. This antinode, this distance, this to this is equal to lambda by 2. Node to node, lambda by 2. Antinode to antinode, lambda by 2. But antinode to node, this is nothing but the lambda by 4. You can remember this. Okay. Now we have to see in the next point the what is mean by the free vibration and the force vibration, which is in next page. What is mean by the free vibration and the force vibration? There are main distinguish between this free vibration and force vibration is that the free vibration, we have to take one example. When the simple pendulum is pulled along a side and release it, then it performs the oscillate on the two sides from its mean position, and it performs the free vibration with its natural frequency. That means it performs the free vibration. Similarly, when a string of the guitar is plucked at some point, then you have to also heard the vibrations. Then these also perform the free vibration with its natural frequency. That means in this free vibration, the body is at its first given an initial displacement and the force is withdrawn. And the body starts vibrating continue and no external force act on the body. There is no need for the external periodic force on that body. Further to keep its motion. And also the free vibration, it is a system. That system vibrates at its natural frequency. In this free vibration, it is a system. That system can vibrate at its natural frequency. And in case of this free vibration, a body, it should be continuously goes on its decreasing the amplitude, and this amplitude should be decreasing. Then it rests to its frictional resistance due to the surrounding medium. It loses some energy, and therefore the amplitude should be vibration. It goes on increasing, and the body should be eventually stop, and the body come to the rest position. Okay, you have to understand this free vibration. Again, main point in this free vibration, this vibration is a system. That means system vibrates at its natural frequency. In this case, the body loses the energy due to the frictional resistance of the surrounding medium. Its amplitude goes on decreasing, and these vibrations stops, and body come to the rest position. Okay, this example, there are the two example of the free vibration, that is the simple pendulum, and second one is the string of the guitar, the vibration of the string guitar. Okay, this is nothing but the free vibration. Now we have to see here the force vibration. The vibration of drill machine and in a washing machine, they are the force vibration. Also, the vibration of the produced by the tabletop due to the tuning fork. You know that in sonometer experiment, this tuning fork can be the tap on the rubber pad, and its stem can be the touch on the wooden table. Then there is also the vibration, and this vibration are nothing but the force vibration. That means they are the force vibration due to the tuning force of the different frequencies. There are the different types of the frequencies of the tuning fork which can be the tuned on this top of the table. Then it should be due to the force vibration. In this force vibration, an external periodic force is applied on this body whose period is different from the period of the force. In force vibration, you have to apply the external periodic force and whose natural period is different for the period of the force. And this body is made to vibrate with the frequency which is equal to that of the external impressor force, and the amplitude of the force of vibration which can be depends on the difference between the frequencies of the external periodic force and the natural frequency, and this difference is very small, and amplitude of the force vibration is large, and then vice versa. So this is nothing but the force vibration. Okay, you have to understand. Well, stop here.